Hi, and welcome to our first in a series of videos on the modulus function. So this is something that is going to be entirely new, and it's a cracker. So here we go. Let's have a look at what we're going to be doing. We're going to be having a look at what the modulus actually means, and then we're looking at sketching graphs of functions involving the modulus, and then doing a bit of equation solving. And then finally, we just need to make sure we spend a bit of time looking at the difference between these two things, which is the difference between y is a function of the modulus of x, and this one is y equals the modulus of a function of x, which might seem like the same two things, but there is a bit of a kind of BODMAS style issue going on there, so we need to look at what's going on with those two things. So, in this video, first one, we're going to have a look at what the modulus is and have a little go at doing some graph sketching before we get on to the other two parts in later videos. Right, here we go. So let's start off with what the modulus actually is. The modulus of a value, and we call it mod x, and it's that x with just two straight lines either side of it, and it's got a very specific definition, which is this. It says, if your x value is equal to or greater than 0, then the mod of x is just x. And if your x value is less than 0, then the mod of x is the minus version of x. Now, let's just have a look at what that means with a simple example. So, for example, modulus of 3. Now, x is greater than 0, so our value 3 is greater than 0. So, therefore, here, mod x is x. That just means the modulus of 3 is 3. Which doesn't seem particularly tricky or enough to cause any concerns. And then if we do the modulus of minus 3, so now in this case, what we've got is our value x inside the modulus is less than 0, so we're looking at the bottom line of diff definition. So we've got to take the negative version of what's inside the modulus, so we want the minus version of minus 3, which is 3. Now, this technical definition is important, but essentially what the modulus function does is simply just says, okay, let's just make whatever value, let's just turn it positive. And using the minus minus is a mathematical way of being able to just turn negatives into a positive. Now, you might be looking at thinking, well, you know what, we're completely overcomplicating things there. If you just go, well, just make it positive, just flip the minus or get rid of the minus sign, that makes it work. And I would agree with you to an extent, but it's important we know that technical definition, because that is going to have implications for how we treat things later on, as we will see. Now, it might be that you've seen these two straight lines before. You'll possibly see them in coordinate geometry. For example, the distance between two coordinates, or you might have seen them in terms of vectors, and they talk about the modulus of the vector, which is the length of the vector, and that is because distances are always positive. So that it might be in that situation there, you've got that notation. It was just a notation thing, but that's the link to what's actually going on with this whole kind of flipping of minuses. So here we go. We've got a function, and you'll have spent some time in previous videos looking at functions. So we've got f of x is the modulus of 2 minus 5x, and we need to find f of 3. So first of all, we're just going to put 3 into that. So there we go. So we've got 2 minus 5 times 3, which is minus 13. And then we go back to our definition at the top and say, well, what's inside the modulus is negative. It's less than 0. So we need minus 13, which makes it positive 13. So f of 3 would give us a value of positive 13. Whereas if we didn't have the modulus either side of these bits, then f of 3 would be minus 13. On part B, let's go f of minus 4. So let's put that in. So now we're doing 2 take away 5 times minus 4. So that's 2 take away minus 20, which is positive 22, which is just 22. And hopefully you're keeping up, and that's all fairly straightforward. Okay, so on we go. And what I'm going to do now is come up with a new function. So this one is g of x, and it's 2 minus mod 5x. Very, very similar. We've still got 2 minus 5x, but this time it's just the 5x part that's inside the modulus. And let's just have a look at what effect that has. So first of all, part A, g of 3. So I've got 2 take away the mod of 5 times 3, which is 2 take away mod 15. And mod 15 is just positive 15, so that's 2 take away 15, which is minus 13. So you can see already on this side f of 3 was 13, but now because by altering the modulus, or what's inside the modulus, we've now got that function saying the value of g of 3 is minus 13. On we go for g of minus 4. So again, so let's get 2 minus 5 times minus 4. Now, here what we've got is 5 times minus 4, so we've got minus 20 inside the modulus. So we're looking at 2 minus minus 20, but because this thing here is the modulus of minus 20, the modulus of minus 20 is actually just positive 20. So what we've got is 2 take away positive 20, which is minus 18, it might have been you were looking at that and thinking, well, that's clearly going to be 22. But when you actually apply the modulus, you find that we've got to take away 20, which is minus 18. So if you have a look at what we've got up here, we know that everything inside here, doesn't matter what value I take for x, I'm going to end up with subtracting this thing here, which is positive. So I've got 2 take away a positive number, which is why both of these have turned out to be negatives. So that was just a case of just kind of getting used to what the modulus is, the definition of the modulus, and what effects playing around with the modulus can have. On we go. Let's have a look at sketches of modulus functions. So what we've got there is the line y equals x. And what I want to do is I want to sketch y equals mod x. And so what's going to happen here is the negative values of x. Let's say if I've got a value here, for example, minus 3, that would give me a value of y was minus 3. That's now become minus 3, so that's going to become positive. So what essentially happens is the line that's been down here is now going to be back up here. So what's basically going on is it's causing a reflection in the x-axis of the negative values of x. So let's just have a look at what's going to happen with these three. So we've got 3 functions that we're going to sketch. Now it is well worth saying that let's say when I wrote this PowerPoint, it was kind of prior the new graphical calculators coming out, and so I'm going to go through it kind of by hand, old school. But if you've got one of the graphical calculators, you can find the modulus function on there, which I think is in the option module, and it's under ABS, which means absolute value. And so a lot of this stuff you can kind of do on the calculator screen now rather than doing it by hand. Having said that, it is always useful to get help with your understanding of doing them by hand, because it really helps you think about what's going on. So let's say I'm going to go through these bits old school, and it might be you want to just kind of check what's going on and make sure you can do these on your calculator as well if you've got a graphical calculator. So having said all that, here we go. We've got y equals mod 3x minus 5. So first of all, what I'm going to do is sketch my original function, thinking carefully about where my intercepts are going to be. So I've got those two, and I've got to remember when I'm doing a modulus, it's the X-Intercept that becomes the important one, because what's going to happen now is this dotted bit here that is negative, it's at this point here, for values of x that are less than 5 over 3, that the bit inside my modulus, this bit, becomes negative, and when that bit inside becomes negative, we then take the minus of it. That flips the dash bit back up, so it's just that bit that's getting reflected. So all we've got to do now is remove that dash bit and replace it with the reflection. And so there you've got your sketch of y equals mod 3x minus 5. Obviously the one piece of information that's missing on there is the y-intercept. It was originally at minus 5, it's been reflected upwards, so that's now at 5, and there we go, there's the complete sketch. Let's apply exactly the same kind of logic to a quadratic in this case. So there we go, we've got a quadratic, we've already done the work to figure out where our intercepts are. We're at minus 2 and 9. And again, when I do these, I sketch them always the bits that are below the x-axis, always put them in dashed. You want to put them in dash, you might want to kind of rub them out later on. And all we've got to do now is reflect the bit that's below the x-axis, above the x-axis, there it is, remove the bit that was dashed, and there you go, there is my sketch of the mod of x squared minus 7x minus 9. Now, it's worth mentioning just at one point here, if I wanted to solve an equation involving these, so if I drew, for example, a straight line across, let's say here, what we're now going to get, you'll see, is actually 4 solutions to the equation rather than 2. But we'll come to that in future videos. And then finally, y equals 3 mod x minus 5. You'll notice very, very similar to part A, but again, I've adjusted where we've put the modulus function. And there's a few ways again about these, but I tend to look at these as a translation of our original mod x function. So I'm going to kind of put that in to begin with. And this is just the thought process that I tend to go through when I'm doing this. I've then got the times by 3, which is a stretch in the vertical direction. So let's put that in. There it goes. And then finally, we've got this bit on the end, which is subtract 5, which is a vertical shift. So that's going to move the whole function down 3. So I'm going to take my green function, move it down, sorry, not down 3, down 5 places. And so there we go. And there's my sketch. Now, as it turns out, I've been a bit of a slacker here because on my sketch I've got some information missing. If it was in the exam, I would imagine that they would be expressly saying you've got to include the X-Intercepts as well. And the easiest way to do that is like kind of previously we knew that that point there is 5 over 3, and because this sketch is symmetrical about the y-axis, that means that point there should be minus 5 over 3. So I really should have put those on the sketch, but really what I'm focusing on in this particular section is just getting the idea of how you deal with the sketching, the idea of lines, portions of the line that are below the x-axis, and the impact of taking something like that, for example, where the modulus is around the entirety of 3x minus 5, compared to where the modulus is just, in this case, just around the x. So there we go. So now I think it would be a good idea to go off and just kind of practice doing those sketches, check them on your graphical calculator, make sure you're entirely comfortable with what's going on with those.